In the last lesson, we learned about C arrays. In this lesson, I'm going to introduce a new type of variable. I'm going to call that variable an index. So indexes go hand in hand with arrays. So we're going to learn about that. We're also going to learn a little bit more about how math works in the C programming language. So it's a couple of very important steps along the way in us developing a more robust algorithm for calculating the average of something. As always, I bring up the command prompt. I type CMD in the search bar. Up comes the command prompt. I click on it. I go cd space desktop, then cd space C code, and I'm in the directory for all my C code. I'm going to make a new project, make project.bat space, and then this new project I'm going to call average v2b. So it's this kind of the second of this version 2 that we're talking about, the second edition of version 2. I bring up File Manager, I open up that file, that folder, and here's the average v2b.c. Then average v2 is still on Notepad++, and so I click on the tab, the leftmost tab that has average v2 in it, Control A, Control C, then I click on the rightmost tab, the one that has average v2b that just has the hello program in it, and I go Control A, Control V, and then I get the last version in this new project, just like before. The first thing I want to talk about in this lesson is a new way of thinking about math for computer programs. And in order to illustrate my point, I'm going to introduce a new variable called sum. And I'm going to add to the sum in sequence. I'm going to add the first element of the A array, then the second element of the A array, and then the third element of the A array, each in their own line. And I know this sounds like adding unnecessary complexity, but trust me, there is a method to my madness in all this. We'll see the point. I think it's next video where it really all comes together. The main point about this these equations, sum equals sum plus a sub 0, sum equals sum plus a sub 1, is that the left-hand side of the equation and the right-hand side of the equation, sum is on both of them. And so the way to interpret that in the English language is to say the new value of sum equals the previous value, or the old value of sum, plus a sub I, a sub 0, or a sub 1, or a sub 2. So the left-hand side of the equation is the new value of that variable, and the right-hand side of the equation is the old value of that variable. You can do that in programming languages, and C is no exception. That's an important point. The new value equals the old value plus something. Then I should say the average is just the sum divided by 3. That makes that equation much simpler. And when I compile it and run it, it runs the same as the original average program, no different. The next thing I wanted to teach in this lesson is using printf in a new way. Up until now, printf was just a hello statement, just kind of an echo to, I'm alive, I'm out here statement at the very beginning. But in all these other average programs, it's just given us the final result. What's the final result? 5.333 is the final result for the average of these three numbers. What printf can do is it can kind of give you insight into what's going on before you get to the end of the program. What's going on in the middle of the program? What's happening? It helps you diagnose mistakes that you might have made, but more importantly, it helps you understand algorithms. It helps you understand things. And so this printf statement is just going to say, what is the value of sum before I add anything to it? I want to know. I want to know what's in that variable, and I just use the printf command. You can see that when we compile and run the program with this new printf command, before we get the answer, we see that before we've done anything, the sum value has nothing in it. It has a value of 0. I assigned it right above that to be 0, so that's why. It is important in this algorithm, when you're using something like sum, is to make sure it starts off at 0. So always initialize things like sums to 0. That's a very important point when you're adding things up, like the way I'm showing you how to do it. Then I want to put the printf statement, the diagnostic printf statement, between each one of those sum equals sum plus things to see what happens. When I compile and run that, you can see the value of sum incrementing. The first value is 0. That was before we added a sub 0 to it. Then it's 3. Then it's 3 plus 5. That's 8. Then it's the previous value, 8, plus the a sub 2, 8, which is 16. So it goes from 3 to 8 to 16. You can watch the sum building up from the beginning of the array to the end of the array using this diagnostic printf statement. Finally, I'm adding this new variable that's going to be used in my array, and I'm calling that an index. I'm declaring a variable I for index, right? That's kind of an easy thing. And I'm declaring it as an int. That means integer, a counting number. 0, 1, 2, 3, minus 1 is an integer. And the integer I can be used as an index. It can replace the values 0, 1, and 2 on my array. I can use it as I can turn the index of the array to a variable itself, the variable I. Then, in this computer program, after I've added the value a sub 0, I'm going to increment I to be 1. And the way I do that is the same as I did with sum. And here, I equals I plus 1. So the new value of I is equal to the old value of I, 0, plus 1. And so the second time it goes, the first time it sees that equation, it has a value of 1. The second time it goes through that equation, it has a value of 2. And so you see now we can variabilize the index of the array. And when we print that out, you can see that I goes up and the sum goes up. And you can see them progress together. So in this video, we've really done 3 things. The first thing we did was we introduced this new type of variable, an integer. And integers can be used as the indexes or indices of arrays. Secondly, we introduced the concept in mathematics that the new value of a variable can equal the old value of a variable plus something. Left is the new value, right is the old value. Left of the equal sign and right of the equal sign. And the third thing we learned was how to use the printf statement to sort of understand what's going on inside the guts of a program. That's a very good diagnostic and debugging tool, the printf statement.